So let's start our class for today. So our class for today will be dedicated to 2 chapters, right? So first, we'll do another exercise regarding chapter number 9, which is about how to build the efficient frontier. هنا ابو خالد مقصر سوى طلبه يجوا بس اتوقع بيطولوا. هذا جاي من اسمه من بوقت حق البي سي ار. شو نسوي؟ So as I told you, so this this class will be dedicated to 3 chapters or 2 chapters, sorry. But first we'll try to do another exercise regarding chapter number 9, which is about من اسمه من البوكس حق البي سي ار. هذا مو من اللمبات. So we'll try to solve the exercise number 4. Then we'll we'll move to chapter number 10 and number 11. So chapter number 10 is very simple. We'll do it in a quick way. It's about how to build the variance covariance matrix. So until now, the variance covariance matrix was done, right? Also was given to us. So now we'll try to learn how to build it using the price that are displayed in the financial markets. يعني ناخذ الحين اسعار في السوق الماليه ومن هنا نقدر نطلع لحالنا بدون مساعده ولا واحد الفارينس كوفارينس ماتريكس. So our main goal is to be able to build the efficient frontier from A to Z without any help, without any external help. We just need the data, right? So let's start by solving exercise number 4. So let me just share the screen with you. So here we are. So we have 4 assets, right, with the following variance covariance matrix and with the following returns. Now, our task is to calculate the envelope for the 4 assets below, and then show that the individual assets that compose these portfolios, which are assets A, B, C, and D, are located within the envelope, right? Page number 247. So we should have something with this, like this graph, right? So now we see here that stock A, B, C, and D that are used to build the portfolios are within the envelope, which means that we can, or all our set are feasible, or the set of all our portfolios are feasible, and that we can rely on these stocks, 4 stocks, to build the efficient frontier, because all 4 of them are located within the envelope. Now, what are the steps to reach this result? How to build the efficient frontier? Knowing that we have here the variance covariance matrix and the mean returns. Remember the steps we have learned to do last class. Standard deviation. We already have standard deviation here in the variance covariance matrix. Remember, the diagonal is composed by the variances, right? For example, 0.1, this one, 0.1, is the variance or the standard deviation squared of stock A. 0.3 here is the square of the standard deviation of stock B, and so on. So we already have standard deviations.
No, we need from the portfolio.
Absolutely. So before moving to the calculation of the return of the portfolio, which is the efficient portfolio, right, which is used by using the data table, right? We have the different combinations. We have first to know or to identify 2 envelope portfolios, X and Y. Remember, we have to find the z vector first. They have to find the composition of, you know, portfolio X. Do the same thing for the portfolio Y, and for both portfolio X and Y, we should, or we must choose arbitrarily two different values of the constant C. So you should learn these steps by heart, guys. So for sure, you will have to deal with such an example in the exam, final exam. So you have to learn these steps by heart. First, find, or first, how to identify two envelope portfolios, X and Y. To do it, you have to fix or to choose arbitrarily two different constants. Generally speaking, we use, for one portfolio, we use C equal to 0, constant equal to 0. And for the other one, you can choose 2%, 3%, 4%, 5%, whatever. The most important thing, the two constants should be or must be different from each other. Once we have identified these two portfolios using the Z vector, right? Then we combine these two portfolios to build the efficient portfolio. Then we can move to the data table, find the different sets, and then build the efficient frontier. So let's start. So I've sent to you an Excel file on the WhatsApp group. So please download it. So we need it. Now, please open or add a new sheet and put it at the start of the Excel file. We'll call it Chapter 9, Exercise 4. Sorry. بنحط عيال جنبه. Okay. So first you have to, to write down this matrix, covariance matrix on the Excel file. So for asset portfolio problem here. لا 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 مسألة انتوا سوحين. You have to write down these, to copy this variance covariance matrix to your Excel file. Yes. Just add a new sheet and name it Chapter 9, Exercise 4. So you can use, this file to review your exam or to review the lecture. So please pay attention to the numbers.
You want us to copy paste the numbers on the.
Yes.
دكتور
تمام.
تبغانا نقرا الجدول هذا اللي
بالضبط اي بالضبط
للأكسل.
صح.
اوكي.
So it should have something like that, right? As I told you, you have to learn the steps one by one. The first step is to build two envelope portfolios. And to do so, we have to choose two different values of the constant C. To make things simpler, we'll use the first constant equal to 0, and suppose for the second one, for example, I will choose 5%, for example. So we'll start by building or by identifying the first envelope portfolio, and we'll call it portfolio X, right? So this is our first task. Step 1. Identify envelope portfolio 1, envelope portfolio X. So for this one, of this portfolio, I will choose the constant to be equal to 0. Now remember, to find the composition of the portfolio X or any envelope portfolio, you need to identify the Z vector. And the Z vector is the inverse of the matrix of variance covariance multiplied by the vector of the risk premium, which is the difference between the mean returns and the constant. خلصتوا يا عيال ولا لسه؟ خلصتوا الاكسل؟ بنات خلصتوا الاكسل يا اولاد؟
ايوه دكتور.
طيب خلينا نشتغل مع بعض خطوه بخطوه. Now, the first thing to do to identify the envelope portfolio X is to find the Z portfolio or the Z vector, صح? The Z vector is equal to the inverse of the matrix of variance covariance multiplied by the vector, what you call the risk premium vector, which is the difference between the mean returns هذول and the constant. Since the constant here is equal to 0, this simply means that the mean returns minus constant will be or remain the same, right? Because we are subtracting 0, so we keep the same vector. So now the Z vector, so it is equal to, sorry, you have to multiply the inverse of the variance covariance matrix by ER minus C. These are the ER vector minus C0. So we'll keep the same ER. So these are the Z or the components of the Z vector. Now we can use it to find the composition or the weights on the sum.
ممكن formula text please.
أبشري. So equal to this formula text. So multiplying the inverse of the variance covariance matrix by ER minus C. Now, since C is equal to 0, so we keep the same ER.
Doctor,
Sam.
Teslam, why we call it constant instead of risk-free rate?
Why we
Call it constant instead of risk-free?
Same thing. The risk-free rate is a constant. Same
Constant
thing.
means ثابت أظن.
ثابت, well, the risk-free rate is constant. That's why we call it a risk-free rate, because there is no change, there is no variation.
Okay.
الريسك مو يجي الريسك يجي من uncertainty، من variation، من التغيرات. لما نقول risk-free rate, which means the risk, or sorry, the rate is supposed to be constant. Now, since we have found the Z, now we can easily find the composition of the weights of each of these 4 assets on the portfolio X. So the X, which is the composition, so it is equal to each component of the Z vector divided by the sum, of all the components. So please check your variance covariance matrix, the numbers. And since we do the same thing for second, third, and fourth component, and since we keep, the sum constant, we should add a dollar sign here, and then we scroll it down. And to check our results, we can compute the sum, which must be equal to 1. C equal to 1. Now this is the formula text. So this is the composition of the first envelope portfolio. We should invest 35.52% on asset number 1, 23.62% in asset number 2, 15.53% almost on asset number 3, and 25.3% on asset number 4. But still, it is not sufficient. Remember, to build the whole frontier, we need at least 2 envelope portfolios, but just 1. So we have to add the second envelope portfolio. So step 2. So step 2, identify envelope portfolio Y. Now for Y, sorry?
What is the reason behind calculate 2 portfolios?
Because in mathematics, Abdurrahman, when you want to build a frontier is a set of portfolios. This set of portfolio is nothing but a convex combination between 2 portfolios. مثل لما تاخذ خط مثلا، خط وش خط هو؟ الخط شلون طلع خط؟ بس يكون عندك نقطتين بس، صح؟ خلاص تجمع بيناتهم تلاقي عندك الخط كله. هنا في الانفلوب عندنا بارابول، ما عندنا خط، فنحتاج نسوي convex combination between 2 portfolios. ايش معنى convex combination؟ يعني كل مره نغير في الاوزان، فمره نحط 20% على اكس، 80% على الواي، مره نحط 30 70، مره نحط 40 60. كل مره نغير في الاوزان تلاقي عندك نقطه، حط نقطه جنب نقطه جنب نقطه جنب نقطه، تلاقي عندك البارابول كله.
بس بالحقيقه دكتور انا ببني محفظه واحده مو محفظتين عشان اوزع بينهم الاوزان.
شوف، لا، انت بتبني محفظتين، كل ما غيرت الاوزان تلاقي عندك محفظه مختلفه، صح؟ هم الاثنين they are composed by the same 4 assets A, B, C, and D. Okay, and the same 4 assets. But every time you change your your weights, you will obtain a new portfolio. Then when you mix up these 2 portfolios together, you get the efficient portfolio. يعني نبدا الحين نبدا من individual assets، نخلطهم مع بعض نلاقي envelope portfolio، ناخذ envelope portfolio مع بعض نلاقي efficient portfolio. Then you have, so to have the second portfolio Y, you must choose another constant. So for example, let's choose 5%. So you can choose 1%, 2%, whatever you want. And then redo the work, which means identify the vector Z, then the vector y, which is the composition of the vector y. Now, pay attention here. Since we have 5%, the difference between, or the risk premium vector, which is the difference between mean returns and constant, will be different from the previous one, right? So let me put it another way. So I call it here ER, expected return, or the mean return, minus the constant. For portfolio Y, so it is equal to the mean returns minus the constant. Since the constant is by nature constant, I must add the dollar sign here and then scroll it down. So this is the vector or the risk premium vector that have to be used to identify the envelope, the Z vector for the envelope Y. So we use the same formula. So the Z vector is the matrix multiplication between the inverse of the variance covariance matrix and the risk premium vector, not the mean returns vector as we did for portfolio X, the risk premium vector. And close the parentheses. So this is the Z. So this is the formula. See here we have negative value of Z, which means we are short selling asset number 1. بيع المكشوف. The proportion for vector Y is equal to the first Z divided by the sum of all the components of the Z vector. And as usual, we add the dollar sign here. And then we scroll it down. And to check our results, we compute the sum of all the weights equal to 1. So should be okay. So this is a formula text. بعدين لسه الحين بنطلع الحين بنطلع الاكس والواي بنفس الوقت. الحين بنسوي الخطوه الثالثه identify the portfolio or sorry compute the characteristics for x and y. طلع mean return او variance وانا بحث اكثر الكوفارينس بعد. Now step 3, once I've identified x and y, now we have to compute the mean, the variance, the standard deviation, and the covariance between these two portfolios. Mean, standard deviation, covariance of x and y. So you have portfolio X, and then, so let's start by here. Mean, variance, then we can compute the standard deviation, and finally the covariance. for portfolio X and portfolio Y. Now the mean for X. We have just to multiply the proportions or the weights by the individual returns of each of the 4 assets composing the portfolio X. So we can use the sum product formula. So equal sum product, this one, the weights of X by the individual returns of the assets composing X. يعني بنضرب الحين مكونات الإكس في عوائد الأصول اللي موجودة اللي تكون إكس اللي هي الأسيت A B C and D وبعدين نجمعهم مع بعض هي sum product نضرب ونجمع في نفس الوقت. So 9.372%. This is the formula text to explain how we got this number. Now the variance, guys. So the variance, we have to use the the M mult function or the matrix multiplication function, because remember, this is when you have to compute the variance of a portfolio composed by different assets, it is equal to the transpose of the composition vector, transpose of X, times S, which is the matrix of variance covariance, times X. So transpose of X times S times X. So we have to use the matrix multiplication twice. So equal. First, we have to multiply the transpose of X by the variance covariance matrix. So this is our first multiplication. Then we should multiply all this expression by X itself, X vector. Zero 0.0862399. So this is the formula text. Sorry. I should move the X here. Now the standard deviation is nothing but the square root of the variance, square root of, sorry, the variance. I can transform it into percentage. And then do the same thing for y. So the mean of y is equal to the sum product of the weights أوزان of the vector y by, now one of the most common error done by students, they will use ER minus C because we use it for the Z vector for y. It's not true. You should use the mean returns. ER minus C should only just be used for identifying the Z vector, only the Z vector. It should not get involved in any other, calculations. So the mean returns. So this is the formula text. Now the variance, as usual, so we should first multiply the transpose of the weights for the portfolio Y by the variance covariance matrix. Then we should multiply all this expression by the weights of portfolio Y. And then the standard deviation square root so clearly Y is riskier than the portfolio X. Now the covariance. So the covariance is the interaction between the portfolio X and Y. So we should use the composition or the weights for portfolio X and the weights for the portfolio Y, as well as the variance covariance matrix. So equal to, so first we should start by multiplying the transpose of the X vector by the variance covariance matrix, and then we multiply all this expression by the weights of the portfolio Y. By doing so we can measure the interaction, because see, we're using both weights of X and weights of Y. So we can measure the interaction between these two portfolios. 0.11692. ممكن بس ما يحتاج calculation زيادة حرص منه. So equal to the covariance divided by the product of the standard deviation of portfolio X with the standard deviation of portfolio Y. 0.
دكتور ممكن الفورمولا تكست.
Okay. Go home. So X and Y are positively and strongly correlated. Not perfectly because it is less than 1, but still it's close to 1. So this is step 3 or step 3. الحين بالضبط لا قبل you have to build first the efficient portfolio which is the composition between X and Y. صح. بعدين نغير البروبورشن حق الefficient portfolio using the data table وقتها نطلع بسهوله efficient frontier. So the step 4 efficient portfolio. So we have to fix or choose arbitrary proportion. We should invest or we must invest in X, and the proportion we have to invest in Y. So we can use, for example, 20% in X, 20%, which means that Y is equal to 1 minus 20%. Don't forget, don't write down 80% directly. 80% must be expressed as a function of the 20%. So the mean return for this portfolio, its variance and its standard deviation. So the mean return is equal to the proportion invested in X times the return of X plus the proportion invested in Y times the return of Y. Now the variance is a little bit more complicated. Is equal to the proportion of X squared times the variance of X plus the proportion of Y squared times the variance of Y plus 2 times proportion of X times the proportion of Y times the variance covariance between X and Y. And finally, the standard deviation is the square root of the variance. So now we are ready for building the efficient frontier.
Doctor, please wait a minute. I think I have a mistake.
طيب.
الكوفارينس دكتور طلع عندي مختلف شيء بسيط.
كام يعني شيء بسيط؟
لا طلع يشبه الكورليشن، سوري، لا يختلف شيء كبير.
لا يعني في غلطة عندك. تأكدت من الفورمولا يا عبد الرحمن؟
جالس اتاكد.
طيب.
ايوه تمام خلاص، شكرا دكتور، معليش.
So step 5, final step. Efficient frontier. Now we need to do this, we need the data table. So now here's the standard deviation. So always start by standard deviation because this is the x-axis, and then put the return or the mean on the y-axis. So standard deviation equal to B46, and the mean is equal to B44. And then we can, change our proportions. So for example, we can start by maybe, I don't know. Okay, minus 300. هنجرب minus 300%. And we can add 10% each time. So minus 290%. Scroll it down until reaching, for example, to 200. So from minus 300 to plus 300. Select all the data table. Go to data, what if analysis, data table. So since we are varying our proportion on the column, Sam.
الأرقام اللي اخترناهم هذه عشوائية صح؟ اللي ماينس 300.
أي عشوائية. بس دائما أحسن شيء تبدأ من ماينس 200% 300% شورت سيلينج اوف يعني اوف.
بس أقصد ما يفرق لو باخذ سالب 300 أو باخذ سالب 100 أو
لا ما يفرق. لا بس
1.5.
لا بس شوف كل ما كان الرانج اكبر، كل ما كان بعدين الجراف اكبر، يعني يكون واضح اكثر.
اضبط يعني.
بالضبط. كل ما صغرتي في الرانج تلاقي بعدين الجراف مو بارابول كامل، تلاقي ربع بارابول، نص بارابول. بس الاجابه صحيحه على كل الاحوال.
دكتور
تمام.
تسلم. لو شلنا افتراض الشورت سيلينج ما حيكون عندنا ماينس ولا اكثر من 100.
صح، وقت يكون من 0 ل 100% بس.
نجرب دكتور يعني بعد اذنك اذا خلصنا هذا.
لا شورت، ما في شورت سيلينج، في عنده لسه فيه شابتر ثاني بيجي بعدين ان شاء الله. في عنده شابتر لسه.
اوكي ثانك يو.
اتوقع chapter 12 I think. So the column input cell here is the proportion of x. So these are the numbers, so I will convert them into percentage. And then I will insert the graph. This is our graph. See here, so we could, build a more broader graph if we go further 20%. If we go beyond 20% here. So let me just try to do it. خلينا نشيل هذا مثلا، نشيل هذا كله. Sorry. خلينا نوصل مثلا 300%. Data, what if analysis, data table, column input cell, proportion of X. It's 1 into percentage. I will select all the possible combinations and I will insert a chart. شفتوا صوت أوضح هنا. So this is our efficient frontier. Obviously, as we have agreed last time, not all the points here are efficient frontier. They represent the envelope frontier, but the efficient frontier is the upper part, الجزء الأعلى. Starting from this inflection point, what we call the minimum variance portfolio. All the points below this point, this inflection point, represent an envelope, but not efficient portfolio. All the points above or beyond this inflection point, all this upper part represent the efficient frontier. Now, the final question was to place or to put the assets 1, A, B, C, and D on the graph and see if these assets belong to the envelope portfolio or outside the envelope. So we can go here. Asset A, asset B, شو؟ شلون؟ اي موجود عندكم؟ مكتوب عند شير سكرين. Asset D, okay. So we have to know the mean and the standard deviation of each one of these 4 assets. So the mean are given to us here. So just to copy them and paste them here. And the standard deviation, we can infer them from the variance covariance matrix, because remember the diagonal, these numbers represent the variances of the individual assets, which means 0, 1 is nothing but the variance of asset A. If I want to find the standard deviation, all I have to do is just to compute the square root. 0.3 is the variance of asset B. 0.4 is the variance of asset C. And finally, 0.5 is the variance of asset D. So here is equal to the square root of the variance of first asset, and do the same thing for the second asset, the third one, and the fourth one. and transform them into percentage and increase the decimals. I have to add these data to the graph. طيب.
Doctor,
Sam.
from where did you get standard deviation for asset A?
حلو. احنا وش قلنا؟ قلنا انه الفارينس كوفارينس ماتريكس ذكرتيها هذه ولا؟ الدايجونال هذه حق كل هي الفارينسز، وهذول هم الكوفارينسز. مثلا هذه وش؟ هذه الفارينس اوف اسيت A، هذه كوفارينس بين A and B، هذه كوفارينس بين A and C، هذه كوفارينس بين A and D. في اي فارينس كوفارينس ماتريكس، اي فارينس دائما الدايجونال هذه تمثل الفارينسز، والارقام اللي فوق وتحت تمثل كوفارينسز، مش كده يسموها فارينس كوفارينس ماتريكس. يعني هذه هي الفارينس حق الاسيت A. اذا بدنا نطلع الستاندرد ديفيشن نحسب لها سكوير روت، صح ولا؟
ايه صح.
نفس الشيء هذا تصير الفارينس حق الاسيت B، هذه حق الاسيت C، هذه دي. ترى مو بس هذه بس، اي فارينس كوفارينس ماتريكس مهما كانت السايز حقها، بتكون مثلا تكون 8 باي 8 10 باي 10، دائما الدايجونال الخط المحور هذا يمثل الفارينسز. And all the numbers above and below this diagonal represent the covariances. That's why we call it variance covariance matrix. وضحت الفكرة؟
دكتور تعلمنا كيف نبني الفارينس كوفارينس
اي اكيد،
ماتريكس.
بعد ما نخلص هذا ندخل مباشر على شلون نبني الفارينس كوفارينس ماتريكس. So this is the formula text for this standard deviation. So from where we got it. Now how to place these numbers on the graph? So you go to the graph, you double click on it, and you have here chart design. You go to select data. So we have to add the new series. So we add here new series of data. So I can call it individual assets, for example, individual assets. So the X values are the standard deviation, and the Y values are the means. And then click on OK. That's it.
Victor, can you again?
Yes, once again. Okay. وش يا ياسر؟
أول ما ضفت
So now how to place these individual assets on the graph, right? So we can do it one by one, or we can do it all together. So let's try it one by one. So maybe it will be, you know, more obvious for you. So go to the chart here, see here, double click on it, double click. So see,
on the same chart.
yes, it's on the same chart, yes. So because we have to check if these assets are within the envelope or outside the envelope. So this is our main challenge. See, you have a new window. الباقي يسمعوني يا أروى. أتوقع المشكلة من عندك.
ايوه انا اسمعك دكتور.
يلا نرجع لموضوعنا وناخذهم واحدة بالواحدة. So let's start by asset number 1, right? So go here and click on select that. See? So we have already a series number 1, which is for the different values of the portfolio. استعملنا في الداتا table. So we have to add a new series. We can call it asset A. Now the X value is the standard deviation of asset A. So I go here and click on asset A. Now the Y values is the mean return of asset A, which is this one. And then click on OK. See, the orange point here is asset A.
دكتور X me the mean or
لا انتبهوا دائما الاكس ستاندرد ديفيشن.
اوكي.
المين هي الواي فاريبل. ترى هذه سؤال حلو لانه هذه بعد اكثر الاخطاء اللي سووها الطلاب والطالبات في الاختبار. اذا خربطت بين الاثنين كل شيء يخرب، كل شيء يخرب. يعني الفكره وش؟ We are trying to build on the variance to find the best or the highest return possible. هذا الشغل كله. فعندما احنا نحدد الاكس قبل كل شيء هي الريسك، في الريسك هذا حددته لنفسك بتحاول تلاقي اكثر او اعلى ريتيرن. فدائما الاكس هي ستاندرد ديفيشن هي في الاكس اكسس on the horizontal axis هنا and the return is on the vertical axis. دائما ذكروها هذه. حلو. See, when you click on the orange here, on the orange, point, see, automatically Excel will select the input, the data you used 31.62 6. شفت انا بنضغط هنا تصير ما فيها شيء. لما تضغط على الاورنج هنا تصير في هايلايت ستاندرد ديفيشن اند مين فور اسيت A عشان تعرف النقطه هذه ترى تابعه هذه بياناتها، يعني هذه اعداداتها. And then do the same thing for B, C, and D. Or we can do it one shot, مرة واحدة بس. So we can go here, select data. So I will delete the series I have added and replace by a new one. I call it individual assets. So I will select all the X values, which are all the standard deviation for the 4 variable. Or for the 4 assets, then all the 4 returns for the 4 assets. And let's click on OK. See, and you will get the 4 assets one shot on the graph. Yes. So, for example, if I click on this one, so we'll highlight all this. But if you click, just put the pointer here. Sorry.
X is standard deviation.
Sorry?
X value is standard deviation.
Yes.
Yeah, it will show a node, it's same as the line.
Yes. So we have here the 4 assets. Now, the most important thing, these 4 assets belong to or are located within the envelope. جوا داخل مو برا. لو كانوا برا ايش معنى كانوا برا؟ So this means ليش مرة مهمة الملاحظة هذه. Remember the exercise we have done last time. I remember that we have built a portfolio with 4 individual assets. 2 of them were located outside the envelope. This means that when we combine these 4 assets, we can never have an envelope portfolio. to have an envelope portfolio and then to have an efficient, portfolio, you must only use assets that are located within the envelope, which is the case here. A, B, C, and D are all together within the envelope, respectively, which means that we can build an envelope portfolio. X and Y are an envelope portfolio, and combination X and Y are represents an efficient portfolio, because A, B, C, and D are located within the envelope. Okay, guys. واضح بنات؟
دكتور يعني هذه الأصول يعني لو نجمع أو الأوراق المالية لو نجمعهم سوا مستحيل يعني نحقق الانفلوب بورتفوليو.
لا هنا نقدر ليش؟ لأنه موجودين جوا الانفلوب. هذه الانفلوب حلو، هذه
بس inefficient دكتور.
هم وحدهم inefficient، بس لما نجمعهم مع بعض نقدر نبني بيهم efficient portfolio، لأنهم أربعتهم موجودين جوا الانفلوب، لكن مثلا واحد فيهم موجود هنا برا، هنا ما نقدر، يخرب الشغلة كلها يعني. So to build the efficient portfolio, you need envelope portfolios, and to build envelope portfolios, you need individual assets located within the envelope. جوا هنا. واضح التفكير أو لا؟ طريقة التفكير.
واضح.
صحيح. أو خلاص نبني البورتفوليو بالثلاث نقاط اللي جوا، وهذه نشيل على جنب. Yes please.
الرسمة حقتي غير حقتك اللي بالأزرق، ما أعرف ليش.
شلون يعني غير حق؟ مو نفس الأرقام حنا؟
إلا نفس الأرقام، بس ما أدري ليش غير.
سوي لنا
أرسلته بالجروب، ما أعرف ليش.
بالواتس؟
إيه اللي بالواتس.
خلينا نشوف. هي نفسها يعني. وش الفرق
لا أنت من تحت يعني يمكن.
بقول لك ليش. شفتي هنا تحت يعني في الحد الثاني يعني في الباوند هذا انت
إيه أنا حاطة إلى 200.
وقفتي 200 صح؟
صح.
عادي خلي 300، وإذا حتكون بعد اكثر يعني اكثر كان متكامله اكثر، خلي 400 مثلا في المية. كل ما وسعنا في الرانج كل ما كان عندنا الرسمه تكون اوضح. بس هي شغلك صح يعني.
اوكي شكرا.
اوكي so ناخذ بريك عيال 10 minutes then we come back. شلون يعني؟
دكتور ما نسمعك.
اوكي واضح الصوت الحين؟
ايه الحين واضح.
حلو طيب. So as I told you, all our work until now was based on the variance covariance matrix. It is a crucial element for our for our work. So we cannot build the envelope portfolio neither the efficient portfolio or the efficient frontier without knowing the variance covariance matrix. But we all know that this variance covariance matrix is not given to us when we are observing the market, right? So we should figure out a way to identify by our own this variance covariance matrix. So there are multiple ways to do it. We just focus on one way using the Excel. We can use the Visual Basic technique, but it requires some, programming. So we just focus on, the variance covariance matrix using Excel. Now, if we want to compute the variance covariance between assets I and assets J, we use the following formula. It's an analytical formula. This one, see? This is the sum of the products of the deviation of the first asset times the deviation of the second asset. So each asset has different possible returns, right? So for each asset, we should be able to find the mean or the average of this asset, right? Then we compute what we call the deviation, which is the difference or the distance between the current observation and the average. Now, suppose that we have an asset with observations through 10 days, right? So the first day, we have a return of 10%. The second day, we have a return of, let's say, 8%. The third day, we have a return of minus 3%, okay? Now, the average over these 10 days is equal to 5%. So on average, this asset offers 5% of daily return, okay? Now, remember, our first observation was equal to 10%. The average is equal to how much? To 5, which means that we have a deviation, a distance between the average and the current observation of 5%. The second observation was equal to 8%, which means we have a deviation of 3% compared to the average, okay? Now we do the same work for all the assets we are observing or all the stocks we are observing. And then we can find the variance covariance matrix. Now, how to transform this analytical formula into matrix computation or matrix calculus? See, here we have in page number 252, okay. We have 5 years of prices for 10 stocks and the S&P 500. So the S&P 500 is the market index of the US market. So it is like Tadawul here in Saudi Arabia, right? So we have 10 individual stocks and the index market, which is supposed to represent all the financial market or all the stock market. Have McDonald's, have US Steel, ArcelorMittal, Microsoft, Apple, Kellogg, GE, Bank of America, Pfizer, Exxon, and finally we have the market itself, the index market. Here we have the prices, right? And we have the market index here, Washar Suq. How? Using these raw data, how to be able to find the matrix of variance covariance. Now, if you go to Tadawul, you will see numbers like these. We'll see the prices of Al-Awthim, price of Al-Rajhi, for example, the level of the index, level index of Tadawul, and so on. How to use this raw data, يعني البيانات الخام, to build the variance covariance matrix. First step, you have to transform them into returns. Remember, as a financial analyst, we don't care about money, we care about returns. So first, you transform these prices into returns. This is what has been done here. So we use the logarithm ln, not discrete time, because here we have a series of consecutive observations. So we use the ln because we have in the continuous time. pt minus 1 for the return of the day t. See, now instead of prices we have returns. Then third step, you will compute the mean or the average for each one of these stocks. Right? So discrete time. You use this technique when you have a discrete observation. What do you mean by discrete observations? Which means we don't have a continuity in our observations. For example, I observe the price of, for example, Tadawul today. And then I have already observed Tadawul 5 days ago. But I don't have observations for the 4th, 3rd, 2nd, or the previous day. So there is a gap. Here we don't have a gap. Here we have monthly data without gaps. See here, March, April, May, June, July, August, June.
And it's the mean for the month.
Yes, for the monthly data, right? If we don't have a gap for our observations, we consider it as a continuous time. For continuous time, we use the logarithm.
Which is daily.
Yes, it can be daily or monthly, or because if we are reasoning on the long run, on years, in terms of years, months are considered as short term, right? If we are reasoning in terms of months, days become short term, right? So here we have monthly consecutive observations. There's no gap. ما في فجوات. شهر ورا شهر ما ضيعنا ولا observation. بنسموه continuous time متواصل. For continuous time, in order to compute the return, we use the logarithm. For discrete time, when you have gaps, we use the discrete time, which is pt minus 1 divided by pt minus 1. Okay. Now, as I told you, we compute the averages, right? And then we compute the excess return, which is the difference between each, monthly, for example, this one. This is a monthly return for March 2007. We have to compute the difference between this monthly observations and the mean. So 3.07% minus 1.63%, which is equal to 0.0144, which is 1.44%. And repeat the same computation for the next month. 6.93% minus 1.63% equal to 5.3%, and so on. So we build what we call the excess return matrix. Then we can find the variance covariance matrix. Which is, see here, it is equal to the sum of the products of excess returns. شفتوا هنا? Divide by the number of observations minus 1. Why minus 1? Because we have a sample. We don't have all the possible data. We have just a sample. So we divide by the number of observations minus 1. So let me just write it down here. So this is the analytical formula, okay? هذا لما نستعمل الرياضيات، نستعمل الإحصائيات. If you want to compute the variance covariance between n assets, the covariance is equal to 1 by n minus 1, the sum. So when we say covariance, we mean interaction between different assets, صح? between assets I and J from N to N. So the return of asset I minus R bar of I multiplied by R, the other asset, J T minus R J bar. Suppose we have, let's say, four assets. The covariance matrix between these four assets is equal to the deviation or the excess return for the first asset with the second asset. Okay. Then the first asset with the third asset. Then the first asset with the fourth asset. So here we have four assets, 1, 2, 3, 4. We want to have the variance covariance matrix. So we should be able to compute or to measure the interactions. One with itself. One with one, we have the variance. Then one with two, we have the covariance R1, R2. Then we have one with three. We have covariance of 1 with 3. And the interaction between 1 and 4, and we have the covariance between asset 1 and asset 4. Then you do the same calculus for 2. 2, 1. You have covariance 1 and 2. So you have 2. That's why we have 2 times covariance. So this one, we have 2 covariance. 2 with 2, we have, sorry, 2 with 2, variance of 2. Then 2 with 3, then 2 with 4. And then 3 with 1, which is already computed here. So we'll have 2 times covariance, 1 with 3, and so on, and so on, and so on. Now imagine if you have to do this work or this task for 100 stocks. You'll be crazy, right? So that's why we use Excel to simplify all this complicated procedure. As if we have here 2 matrices. This one is the deviation, the first deviation. This one is the second deviation, صح? Divide by number of observations minus 1. I can rewrite this analytical formula using the matrix, and it becomes M multiplication, M mult. As I told you, the matrix of the excess return with itself. يعني أخواني مثلا X transpose of excess return by the excess return. هتسميناها interaction between the matrix with itself. So the multiplication of the transpose of excess return matrix by the excess return. Excess return matrix هي هذه. بس. So this one. We have computed the return, and then we have subtracted the means from these returns, and we got the excess return. The variance covariance matrix, شفتوا هذا هي الفورمولا, is the multiplication of the transpose of B83 تبدأ من هنا until K142, which is what we call the excess return matrix, by the excess return matrix itself, divided by, we have 60 observations, n minus 1 becomes 59. That's how we can find the matrix of variance covariance using the prices. I know it's a bit complicated, so we need to practice. So please open your Excel file and وين؟ اللي موجود ما راح احط لك كل واحد. طيب وين هذه؟ هذا هنا. So you go to chapter 10 exercise 1 هذا. So here we have already the matrix for for the returns. ما اعطانا price اعطانا returns مباشر هنا. 4 1 2 3 4 1 2 3 4 5 6. Six stocks. You are asked now to compute or to identify the variance covariance matrix. So what would be your first step?
calculate the average.
The mean.
Absolutely. Try by computing the means or the averages. Then find the excess return matrix. Then we can easily find the variance covariance matrix. So we go here and I will add a new row, we call it mean. So here we have the annual returns. So the average of the past annual returns, 29.24%. And I will scroll it to the right-hand side. So these are the means or the averages for the 6 companies. Now, the next step is to compute what you call the excess return matrix, which means for every one of these individual stocks, we will transform these annual returns into annual excess returns compared to their means. So I will call it here excess return matrix. From 1982 to 1992. شو؟ وش اسم الشركات؟ ماكدونالدز هذا رموزهم رموز. ما فهمت ياسر. هذا قصدك هذه يعني هذه هذا وش اللي يختلف يعني؟ هذه رموز ام سي دي يعني ماكدونالدز. زادوا اللي تحته اكس ام تي ام اس اف تي. وين الفرق يعني؟ هذه بدنا نصلح لنا. اي بصير عليه الحين. هو مشكلة دقيقة بس، احنا ما نحتاج هذا الحين. احنا لسه هنا احنا لسه في الجدول هذا في الاكسس ريتيرن احنا. اوكي بعد نوصل نشيل تواريخ. So the excess return matrix. So for each column, now we'll replace the returns by the excess return, which is the difference between the return and the average. So for the first company, equal to the first annual return minus its mean. The mean is by nature constant. So we should fix the cell by adding the dollar sign. 7.42%. And then scroll down for the remaining dates. Do the same thing for Kimball, Flex Steel, Leggett, Herman, and Shaw. So equal to the first return minus the corresponding mean without forgetting the dollar sign. Yes, we can. Minus mean. But if you do it, you have to pay attention to the dollar sign. You have to put just $1 sign, not two. If you put $2 sign, you will keep the keep the same cell. But you need also to translate or to move to the right hand side with the means also. عشان نحط أقول شو نسويها دقيقة بس. عند dollar sign هنا sorry. So if you want, for example, to see here, to scroll it to the right hand side, in order to avoid to do the same work over and over and over again. See here, we have A3 minus D15. So we are computing the Leggett and Platt deviation compared to the Flex Steel mean. So to do so, we go here. We just keep $1 sign. Sorry, not this one. See here. So your attention, please. Okay, I will repeat once again. So I will remove all these numbers. Now we have agreed how to compute the excess return for the first company, صح? So this is the formula text. For the last row. So B13, for example, for the last one, B13 minus B15, which is the mean. Now, in order to simplify things, sometimes you have to deal with 20 stocks, 30 stocks, sometimes hundreds of stocks. So we not repeat the same work for each column, right? So we have to figure out a way to do it one shot. So Yasser has proposed that we scroll down at the right hand side. Here. Right? Now, if we check this for the Kimball company, click right here. What's the formula? C3 minus what? B15. So this is the C3. This is the annual return for Kimball. Minus B15. What is B15? The mean return for lazy boy. Right? So we are changing the returns, annual returns, but we are keeping the average for another company, which will result in wrong calculus for all the table. So we should be able, or we must figure out a way to moving the means here right? When we move from one company to the other company. So we go here for the lazy boy. So B13, we delete the first dollar sign. We keep the second one. When we do so, we give instructions to Excel to free the columns. We are no longer obliged to just keep the column B because we have deleted the dollar sign. Now we can move from column B to C to D to E to F to X to Y to Z, whatever we want. But we fix the row 15, which means we can move from B15 to C15, but not from B15, for example, to C20. We are we are, you know, deleting constraints on the columns, but keeping the constraints الحواجز أو العوائق for the row. So we can move through the columns, but within the same row. نفس الخط 15. When we do so, and when we scroll down, when we scroll to the right hand side, now see here becomes C13 minus C15. The next one, D3 minus D15. The next one, E3 minus E15, and so on. Now to do it at one shot, so I will, you know, delete all this one. So B13 minus B15. Okay. Now I will select all these cells and then scroll them all together to the right hand side. And that's it. So we can do it at one shot, with one shot. Now we can easily find the variance covariance matrix. So we go here. So the next step is the variance covariance matrix. So we need to know how these 6 stocks will interact with each other. See? Now remember, the variance covariance matrix is the multiplication of the transpose of the excess return matrix by itself. So it is equal to here matrix multiplication of the transpose of the excess return matrix by the excess return matrix.
دكتور معلش تعيد.
يلا. sorry نسيت شيء. So we should divide by n minus 1 صح. So divide by, so how much observation do we have here? We have 11 observations. شو مع بعض 11 sorry سأشيل هذه هنا. So number of observations, so we select them to have count 11 observations. N minus 1, it is equal to 10. So we go here and we divide by 10. طيب نعيدها مع بعض. So I will delete all these numbers. So now we want to find the variance covariance matrix between these 6 stocks. Remember, this is how we compute the variance covariance matrix by multiplying the deviations or the excess returns of the different, stocks. Here we have 6 stocks. So we are multiplying here the excess return by the excess return of other stocks. So which means we have to multiply the transpose of excess return matrix by the excess return matrix. Remember, the excess return matrix has 6 columns and 11 rows صح. يعني عندنا 11 سنة و6 أسهم. هذه الاكسس ريتيرن، هذا هو الماتريكس اوف اكسس ريتيرن. شفتوها فيها number of rows من 82 إلى 92. لما نحسبهم مع بعض we have 11 rows and then we have 6 columns. So to multiply this matrix by itself, يعني الاكسس ريتيرن matrix has the dimensions of 11 by 6. Now we want to multiply the excess return by itself صح ولا؟ هذه هي المعادله. اذا نضرب excess return by itself نضرب في نفسها يعني مثل ما سوينا هنا نفس الماتريكس. شوف الانتراكشن حقها مرتين. We cannot do it directly because excess return, if we want to do so, is also with 11 and 6 dimensions. And we know that to multiply one matrix by another, the number of columns for the first matrix must be equal to the number of rows of the second matrix صح؟ مش كده سوينا transpose of excess return. The transpose becomes a matrix with the following dimensions 6, 11. Now by 11, 6, we get 6 by 6, which is the square variance covariance matrix. Now how to do this or these tasks using Excel? So it is equal to, I have to multiply the transpose of this excess return matrix. So matrix multiplication, the transpose of the excess return by the excess return itself, and the whole thing, is divided by the number of observations minus 1. Since we have a sample, we have 11 observations, minus 1 becomes 10. So divided by 10. So this is the matrix variance of variance covariance. This is the matrix of variance covariance. These numbers here represent the variances. While the numbers below and above this diagonal represent the covariances. And since the variance covariance matrix must be symmetric variance, the numbers above the diagonal should be the same numbers below the diagonal. So this is one way to check if your answer is the right one or not. For example, so see this one, it is replicated here. This one, we'll find it here. This one, we'll find it here. Remember when we computed or we make this graph. So each covariance will be duplicated twice. So we say 2 times covariance of R1 with R2, 2 times covariance of R1 with R3, because each covariance will be repeated twice. This one, you will find it here. This one, for example, you'll find also here. Yes. So equal the formula text.
Doctor, why divided by 10?
Because we have a sample. Remember what you have seen during the 5th chapter. When you have a sample, you divide by the number of observations minus 1 for the covariance. When you have the whole population, you divide by the number of observations. In 99% of cases, we will deal with samples. So we'll divide by n minus 1. ذكرتوها المستوى كده شوفها. لما نحط مثلا if you want to compute the covariance, so covariance شيء عنه covariance P covariance S صح ولا ذكرتوها هذه. The P is for the population, the S is for the sample. The difference is for the population we deflate by the number of observations, while for the sample we deflate by the n minus 1. That's why we divide by 10, not by 11. واضحين ولا؟ Now please move to the next sheet. Now you should be able to do it by your own. We have here the data for 6 stocks: Hewlett and Packard, Pfizer, El Paso, Teva, Kellogg, Ford, and the index S&P 500. Yes. Now you should find the variance covariance matrix, but pay attention here. Here we have the prices, not the returns. Have prices. See, price data. We have monthly price data. وشو؟
اسرع واحد له بوناس دكتور.
طيب طماعين صرتوا. دقيقة بس. شوفوا هذا ال 10. So compute. هذا مطلوب منكم. Sorry. The returns of the data and the statistics for each of the assets, mean, return, variance, standard deviation of return. Okay. البيتا تنسوها شوفوا بعدين البيتا خلوها على جنب. Then compute the sample, variance, covariance matrix and the correlation matrix for the 6 stocks. نفس الشيء correlation matrix سيبوها. مطلوب منكم الحين تسوي returns of the data, right? Then for each of the assets, mean return, the mean, the variance, the standard deviation, and then build the variance covariance matrix. يلا بسرعة. صح 2 3 اكتبها هي. اللي خلص بده ياخذ بونص يسوي الشير سكرين. ها pause the recording. Okay, so let's go to the
ضرب الطاية.
وش يا علي؟
أنا ما أدري صح ولا خطأ، أو يبدو لي خطأ للأسف.
خلاص. طيب.
ممكن بس بالجروب.
لا خلاص سكرنا الحين انتهينا.
أبد خير يلا. الله يعافيك.
الله يعافيك. طيب. So first step, as I told you, we have to transform these data from prices to returns, صح? So we go here. So instead of prices, returns data. This is the most or the oldest date, and this is, see here, the most recent date. So pay attention. When we compute the returns, we start from this one. So this is the most recent date. Or we can, rearrange or reorder these data from the most recent to the oldest one. So we can do this job. So we can select all this data here. Sorry. Select the data. I will paste it here. Now see, I will select the column for the dates here. I go to sort and filter and sort newest to oldest. Then I will expand the selection here and sort. See, so now we have from the most recent to the oldest one.
Can you do it again, please?
Yes. So this is one of the most common mistakes, which is sometimes made by students. So they didn't pay attention to the fact that here the data are ordered or is ordered from the oldest date to the most recent date. So in such case, if you want to, for example, to compute the return for January, you cannot make January divided by February. Because January is, okay, so you can start from this part and go up, or you can reorder the data from the most recent to the oldest data point. You can do it in a very easy way. So see, I will select the data here. I'll paste it, the same data, really, see, the same data. Now you go to the date column, you select all the dates. See here. واضح? Then go to sort and filter. See, sort and filter. We have sort oldest to newest or sort newest to oldest. So we look for to have the newest data first. So we go here, sort newest to oldest. Now Excel will ask you if you want to expand the selection for the other, columns, or just limit the modification to the date column. So you see expand the selection, which means you will order all the prices from the newest to the oldest. So expand selection, click on sort and see. نرجع هنا. طب هدول الديت صح؟ هنا شفت في الهوم. To the right hand side على يمينك آخر يمينك. Sort and filter. So sort and filter. Then you choose the option So sorry. So first you have to select the dates here. Then go to sort and filter. So automatically the X will detect that these are dates. So he will propose you to sort from oldest to newest or newest to oldest. We want the second one, newest to oldest. And we want to expand the selection to the other columns. Sort. Sorry. So sort, newest to oldest, expand, and sort. Reap.
Sort oldest to newest.
So I have to select all this data. Copy the data here. Date here. Here we are. So see, so now we have the data reordered from the newest to the oldest. So the last row on the first table becomes the first row in the new table.
الدكتور اعتقد انه بدا من 2013 بدا من الاولدست.
لا عاد بالعكس الاولدست هي 2010.
اوكي.
So we go here. So we got the table here for the dates. We've got the dates here. Now the returns, okay? So equal for Hewlett-Packard, for example, January 2013, so logarithm, ln, this one, January 2013 divided by December 2012. And then double click, we got.
دكتور انت تسوي معكوس المصفوفة يدوي؟
شلون يعني؟
يعني ليش اخذت العكس بالتواريخ وحتى
لانه لما نحسب اللوغاريتم دائما نحسب الاحدث قسمة الاقدم.
بس وش النتيجة اللي نبغاها هنا يعني؟
هنا ريتيرن هذا. حولنا الهيولت باكارد هذا من برايسز تو ريتيرنز. And see we lost the last observations. Then do the same thing for the other. For example, this one is equal to H49 by H50 and so on. So it's the formula text. So now we have transformed the prices into returns.
دكتور
سم.
تسلم. مو المفترض نقسم خلية 50 على 49؟
وشو؟
مو المفترض نقسم خلية 50 على 49؟
لا لأنه إحنا غيرنا الترتيب هنا. 50 صارت وشو؟ صارت ديسمبر 2012 صح؟
صارت الجديدة يعني.
بالضبط، صار الأجد منها جانوري 2013.
دكتور ليش طيب غيرنا الترتيب؟
عشان إذا سوي كده مثلا إذا سوينا كده مثلا أوكي سوينا خلينا الترتيب زي ما هو. سوينا لوغاريتم هذه قسمة هذه. اوكي شفتي هذا خطأ، يعني قسمتي القديم على الجديد.
لا ممكن عادي العكس.
يمكن تسوي كذا، اول تسوي العكس، تسوي كذا مو باش تسوي كذا، تبدي باللي تحت وبعدين اللي فوق. مثلا
بس انت قصدك يا دكتور
هو
ترتيب.
اكثر ترتيب، بس عشان يكون الترتيب واضح نبدا دائما من الاحدث الى اقدم واحده فيهم. هذه الفكره وبس.
ولا ما يهم الريزولت؟
لا ما يهم، المهم يكون الريزلت صح. سأقول لكم حسب التجربه اكثر الاخطاء لما يتخرب الترتيب الطالب يتخرب. فاحسن شيء تسوي اول شيء انك تنظمهم من الاحدث الى الاقدم، from the newest to the oldest.
دكتور بالاختبار عادي إذا ما رتبناهم سويناهم زي الطريقة
بكيف؟
الثانية؟
المهم اعطيني بس في الاخر نتيجه صح.
شكرا.
يعني احنا عدنا ترتيبهم بس عشان يعني نحسب اللوغاريتم كذا
بس
يعني.
اي صح.
اه
الحين اللي بعده هو شو؟ نحسب الافريج او المين. So this is the average. هذا اول واحده فيهم for Hewlett Packard. Then we scroll to the right hand side and we got the average for the remaining securities. Then the variance. Now for the variance, you have to use the variance.s because we have a sample of the whole population. So the variance S close the parentheses. And then scroll it to the right hand side. So we have here the formula text. Then the standard deviation, which is the square root of the variance and transform them into percentage. Then the final step. سمي.
معلش بس تعيد الفاريانس.
هذه هي variance. So no need to. So you can directly use the built-in Excel function. So equal var. So when you type var, you have two options: var.p, var.s. P when we have the whole population, which is not the case here. We have just a sample. عندنا عينة بس. So we use the var.s. Then we select all the returns for Hewlett Packard. Then close the parentheses. Then you scroll it to the right-hand side. If you use the var.p, you will find different results. Now the next step, you have to transform this return matrix into excess return matrix. And pay attention, do not include the S&P 500, just the 6, individual stocks, 1, 2, 3, 4, 5, and 6. So now I will build the excess return matrix the date here. So I will not select S&P, just the 6 individual stocks. Now for Hewlett Packard is equal to the first return minus the average return. I will put $1 sign. Sorry. Then 1, 2, 3, 4, 5. So these are the formula text. So here we are subtracting K86, L86, M86, and so on. So we are moving through the averages. And that's it. Now, the final step is to build the variance covariance matrix. Variance covariance matrix. So it will be quadratic matrix with 6 columns and 6 rows. Equal to matrix multiplication of the transpose of the excess return matrix, this one, by the excess return matrix. Now we have 36. How much observations do we have in returns? Abbassi. I will just select the number of. So we have 36, right? Okay, so we subtract 1. So equal, so this 1 divided by 35. And this is our matrix of variance covariance matrix. Equal to formula text for the first cell. This is your answer. So you should find the following result. So now we are able to make the whole analysis from scratch based only on the raw data of the market. هنقدر بس يعطيني بس هو يعني اسمه اسعار الاسهم. انا اسعار الاسهم بقدر اطلع الفاريانس كوفاريانس ماتريكس، بنطلع منها الانفلوب بورتفوليو، بنطلع منها الانفلوب فرونتير، الفيشنت فرونتير في الاخر. بس يعطيك بس وشو اسعار الاسهم بس، وانت تقدر تسوي الشغل من اوله لاخره.
طيب دكتور، لما اخلص واخر شيء واطلع الانفلوب فرونتير،
فيشنت فرونتير
اقدر اطلع يعني اختار من الاصول هذه يعني اشياء اطلعه من المحفظه وشيء اخليه؟
تقدر اي
كيف؟
على كيفك، عاد انت اختياراتك، هذا يرجع لك انت. يعني ان هي عندك بعطيك الاصول كلهم صح، كل اصول تعرف مين ريتيرن. انت اذا تلاقي مثلا واحد منهم ما يناسب الريسك افيرجن حق الريسك بريفرنس حق تو ريسكي مثلا تشيله. بس هو في الاغلب الحالات يخلوا كل، يعني يخلوا كل اللي اسمه يخلوا كل الستوكس اللي في الماركت.
طيب دكتور، سؤال يعني بطريقه ثانيه، يعني انا ليش احتاج احسب البورتفوليو افيشنت فرونتير؟
ليش تحتاج؟
ليش احتاجه؟ ايوه.
وش معنى efficient portfolio عبد الرحمن؟ efficient portfolio is a portfolio for a given level of risk. This portfolio will offer you the highest return possible. انت تحدد نفسك وتقول انا مثلا اذا استثمرت ما قبل مخاطره اكثر من 10% مخاطره، شوف ال 10% هذه حددتها لنفسك انت. الefficient portfolio يعطيك البورتفوليو اللي فيه اكثر عوائد ال 10% مخاطره اللي انت حددتها لنفسك.
يعني مو عشان احذف او اضيف اصول جديده عشان اوصل
لا شوف،
للبورتفوليو.
احنا قلنا في عندك نوعين من الانفستمنت استراتيجي. اذا بدك الحين تحذف كل مره تحذف وتغير تسوي ابديت، هذا لا، هذا الاكتف استراتيجي ما تطبع على الطريقه هذه. احنا نحكي الباسيف استراتيجي، احنا نحكي انك تشتري يعني تسوي محاكاه للسوق، تسمى ماركت دوبليكيشن، تسوي زي الماركت بالضبط وتستنى بس. واللي بيصير بعدين انك الحين راح تغير مثلا البروبورشن اللي تحطها استثمار في الماركت مقارنه بالريسك فري اسيت. اشوفه بعدين هذا في المحاضرات الجايه مع الكي بي ام.
اوكي ان شاء الله.
اروى، امل، بتول، شروق، عهد، مرام، مريم، ملاك، ميسون، نوره، بنات كلهم حاضرين اتوقع. والعيال نفس الشيء. طيب خلصنا اليوم، يعطيكم الصحة.
معلش
ايه
السي فاليو وطلع الويت بعدين
بالضبط ايه
الكونستنس من عندي
من عندك، اي مشكلة.
ها؟
ما يفرق معك، الهدف مو الكونسبت، الهدف في الاخر تطلع efficient frontier.
اوكي
بس فرونتير يبي لك تو بورتفوليوز، عشان كده قلت تو بورتفوليو ما يهموك اللي اختار الكونسبت تبيهم انت. هم تو انفلوب بورتفوليوز، لما تخلطهم مع بعض تلاقي efficient frontier. طيب خلصنا اليوم، نلتقي ان شاء الله الاسبوع الجاي.